I don't have any spares. I only had printed enough for everybody to have one. It's okay if it ripped. You can just tape it later. Okay? Alright, guys, let's go ahead and go over this. Alright. For angle A is equal to x, 10x plus 13. Angle B is 6x plus 23. The angles are supplementary, so we're going to draw a diagram. We're going to set up the equation, and then we're going to solve it. So drawing a diagram, if it's supplementary, what should it look like? Like, what's the final formation going to look like, Ray? Should be just like a straight line, right? Supplementary angles kind of, when they're finished being formed, it looks like a straight line. You might have just some kind of angle or a ray coming out from in between them. Okay? So it probably looks something like this, where you've got angle A, which is 10x plus 13, and then angle B, which is 6x plus a 23. Okay, so there is the diagram. Now, the equation, what will the equation look like? Alex? Good. 10x plus 13, that's angle A, plus 6x plus 23 for angle B, and it's going to be set equal to 180. Because of the fact that it's a supplementary angle set, it's going to be set equal to 180. So now we've got these equations that we're going to have to solve. We've got the equation that we have to solve. So what do we need to do first before we can actually start solving it, before we can start doing inverse operations? What do we need to do first, Armando?
With the numbers, with the variable in one,
So
like
add them together, right?
Yeah.
Combine like terms. That's what you're going to be doing. You are simplifying this set right here. You're going to combine those like terms together by combining the variables together. So we know that 10x can be combined with a positive 6x. And we also know that a positive 13 can be combined with a positive 23. So we're going to combine those values together. What is 10x plus 6x going to give us, guys? 16x. Good. All right, and then what is 13, a positive 13 plus 23 going to give us? 36. A positive 36. So I want to make sure I write that down. I'll go ahead and put that in my black ink again. It's a positive 36. And this whole thing is set equal to 180. All right, now that we've got it simplified, we can go ahead and start solving it. What is the first step that we're going to do to solve it? First inverse operation for solving here. Bridget? Good. We're going to subtract 36 from both sides. Subtract 36 from the 180. Okay, that's going to leave us with 16x on the left side. And then 180 minus the 36 is going to give us 144. Okay, last step. What's the last step to do here? Let's go with Dakota. What's the last step? Divide them both by 16. Good. So we'll divide both sides by 16, and x is going to wind up equaling 9. You should have gotten x to equal 9. Okay, if you were to substitute this back in to find out what each of the angles would be, you could do 10 times the 9, which is 90, plus the 13, that's going to give you 103. Then you could do 6 times the 9. 6 times 9 is going to give you 54. 54 plus the 23 is going to give you 77, which makes sense because 103 plus 77 should equal 180. It's a nice and easy way to be able to check that you did it correctly. Okay? All right. For number 2, same set of angles, but this time we're saying that they're complementary. They're complementary. What is the diagram going to look like if it's complementary? What's the shape look like? Go ahead, Paris. Like half a box or an L, right? Kind of looks like the letter L a little bit. So, or exactly like the letter L. You've got half of a box here. It's 90 degrees, so it's going to have that right angle in there. And then you're going to have it cut off. You're going to have a ray that's going to kind of go through it. Where again, you've got 10x plus 13 for one of the angles. And then 6x plus 23 for the other angle. And it's the same exact equation, except there's only one thing that's different. What's the only thing that's different with a complementary angle equation? Maya? The sum. What is it? Instead of it equaling 180, what is it going to actually equal? 90. Good. All right, so we have it 10x plus 13 plus the 6x plus 23 is now going to be set equal to 90. And we already know that we had to combine these like terms that we're going to be combining that 10x plus the 6x. That's going to give us that 16x. We already know that we're doing that positive 13 and that positive 23 to come out to the positive 36. So all of that is still the same. It's just set equal to 90. All right, so same process. Subtract the 36 from both sides. You're not going to get 16x. It's going to be set equal to 54. And then the last step would be to divide by 16. And you'll get a decimal. X is going to be equal to 3.375. Okay, and of course you could always plug it back in to work it out. Make sure it sets up and equals 90. Let's go ahead and move on to 3. Same set of 8 angles, but this time it's vertical angles. Vertical angles. What is the diagram going to look like this time for vertical angles? Veronica? Kind of like an X, right? They're intersecting lines. Okay, and then you're going to have 10x plus 13 on one side. You're going to have 6x plus 23 on the other side. And what will the equation look like for this one? Trey? Very good. So with the vertical angles are set equal to each other. All right. So there's nothing that you can simplify on either side, so now you just have to start solving. What do we do first? Armando? Very good. So you're going to subtract the smallest of your variables from both sides. Or you might add the smallest of the variables, depending on what it is. If it was a negative, you would add it. But since it's a positive, we're going to subtract it. We're going to remove the smallest of the two variables from both sides. Okay, 10x minus the 6x is going to leave us with 4x. So we now have 4x plus 13 is equal to a positive 23. All right, and then we follow those simple two-step rules. Subtract the constant from both sides first. So we're subtracting 13 from both sides. That gives us 4x is now equal to 10. And then divide both sides by the 4. And we'll get x is equal to 2.5. All right, last one. Angle A is 14x minus 18. Angle B is 5x plus 13. If x is equal to 5, what type of angle relationship do angle A and B have? Okay, so for a problem like this, you're just going to set it up to substitute. You're going to set it up for substitution. Okay, so we're replacing the x's that we have for each of the angles with the value of 5. So we're going to have 14 times 5 minus 18. And we're going to have 5 times 5 plus 13. Okay, 14 times 5 is going to give us 70. And then 70 minus the 18 is going to give us 52. Here, 5 times 5 is going to give us 25. 25 plus 13 is going to give us 38. Okay, so right off the bat, I know that they're not vertical. How do I know they're not vertical angles? Because they're not equal. Good. So that means that they're either going to be complementary or supplementary. Which one is it? Complementary. If you add them together, they're going to equal 90 degrees. So that makes it a complementary set. Any questions? All right, we're going to go on real quickly to our next page, which is going to be on triangles. So real quickly, we're going to talk about triangle classifications. So triangle classifications has two ways of classifying the triangle. You can classify it by angles, by the type of angle that the triangles have, or you can classify them by sides. So if we classify them by their angles, you've got three kinds of classifications. You have an acute triangle, which means that all three angles are going to be acute angles. What's an acute angle? Veronica? Less than 90. That means all three angles are less than 90 degrees. All three angles are going to be less than 90 degrees. Okay. If it is a right triangle has exactly one angle that is a right angle. Exactly one right angle. What's a right angle? 90 degrees. Okay? Exactly one angle that equals 90 degrees. Okay, you can't have more than one. Can't have more than one, because if you have more than one 90-degree angle, are you going to be able to make a triangle? No. Look, here, I'll put a post-it note up here so you can see. Here's a 90-degree angle. So if I try to do another 90-degree angle, I cannot close it to make a triangle. It's impossible. With a triangle, you cannot have more than one 90-degree angle in it. Okay, so it'll look kind of like this. Your acute has all three acute angles. Then we've got obtuse. Obtuse triangle has exactly one angle that is obtuse. What does obtuse mean? Greater than 90 degrees. So only one, because again, just like the right angle, you can't have more than one right angle. You can't have more than one obtuse angle either. It's greater than 90 but less than 180. Has to be less than 180. Okay, so it's going to look something like this. Okay, the second way that we can classify angles, or triangles, is by their sides. Side classifications. Side classifications. So if we've got a scalene triangle means that all the sides have different measurements. None of them are equal to each other. So it might look kind of like that, where they'll put little lines in them. And those lines represent measurements, saying, okay, well, this is a measurement. This has a different measurement than the first one, and this third one has a different measurement than the other two. So they're called congruency symbols. Congruency symbols. And if all the sides are different, then that means all of the angles are also going to be different, because they correspond with each other. If all of the sides are different, that also means all the angles are different. Alright. I'm going to use a color I don't normally use just because because I have 6 that I need to do. But isosceles triangles. Isosceles triangles indicate that there are at least 2 sides that are equal. At least 2 sides that are equal. So it's going to look something like this. So again, those congruency symbols, the single line means that those 2 sides are the same. The double line means it's different than the others. Now, if at least 2 sides are equal, hold on. Let's go on. So if at least 2 sides are equal, then that means that at least 2 angles are equal as well. So just like these 2 sides would be equal, then that means that these 2 angles right here are the ones that would be equal to each other. All right, our last one is our equilateral triangle. And with equilateral triangle, all sides are equal. All 3 sides are going to be equal to each other. Okay, and since all 3 sides are equal, then all 3 angles are equal. And in fact, they all 3 will equal 60 degrees. All 3 angles will be equal to 60 degrees. If it's an equilateral triangle, then each one of the angles is going to be 60 degrees. And how I know that they're going to be 60 degrees is because of this theorem right here, the Triangular Sum Theorem. So the Triangular Sum Theorem states that the angle, all 3 angles, if you add them together, it's going to equal 180 degrees. So angle X plus angle Y plus angle Z, that's going to be set up to equal 180, no matter what type of triangle it is. It does not matter. Doesn't matter if it's scalene, doesn't matter if it's acute, doesn't matter if it's obtuse, isosceles, any kind of triangle. All 3 angles added together will always equal 180 degrees. So it's important for you to remember that all triangles are 180 degrees in their measure. So when you are solving for a missing measurement, you set up an equation that is set equal to 180, where you add all 3 angles together. So for this first one, we have x degrees, because we don't know what this is. This is supposed to be our x. I'm sorry if this is hard for you to see, but this is 68. So I'm going to add 68. And this one is 47 down here. If you can't see that, that's supposed to be 47. So if I add all 3 of those angles together, it's going to be set equal to 180, and then I can go ahead and solve them. Before I start solving, I got to simplify. So I'm going to simplify these constants first. This positive 68 and this positive 47. When I add those together, that's going to be equal to 115. So I have x plus 115 is equal to 180. And then from here, all I have to do is subtract 115 from both sides. And we're going to get that x is going to be equal to 65 degrees. Okay? So knowing that x is 65 degrees, and that this is 68 and this is 47, what are the two ways that I can classify it? So let's start first with the angle classification. Is this an acute, a right, or an obtuse triangle? Acute, right? All three angles are less than 90 degrees. So we know that this is acute. Okay? Now for the side classifications. We don't have side measurements written here, but I do have these angles written here that will give me a hint about the sides. Is it scalene, isosceles, or equilateral? Scalene, right? All of the measurements are different, so that means it's going to be scalene. All right, number 2. We have A degrees plus 41 plus, what is this measurement? 90. And that's set equal to 180. Okay, so we can add the 41 and the 90 together. What's 41 plus 90? 131. Good. So we get A plus 131 is equal to 180. Then we're just going to subtract the 131 from both sides. Okay? And we'll get A is equal to 49 degrees. All right, start with the angle classification. Acute, right, or obtuse? Right, it's got a right angle right here. The right angle, so it's a right triangle. Scalene, isosceles, or equilateral? Scalene. All three angles are different, so therefore this is going to be different. Scalene. All right, number 3 is a little bit different because we don't have a measurement for any of the triangles or any of the angles. They're all variables, but it's still the same process. We're going to take 4x plus 6x plus 2x and set it equal to 180. Right? We just take each of these angles. This was 4x. This one was 6x. This one was 2x. And we combine them all together. So what is 4x plus 6x plus 2x? 12x. So we have 12x is equal to 180 degrees. So this time we're going to divide by 12. Divide by 12 and we'll get x is equal to 15. Now, the thing is that doesn't tell us what the angles are. I know that they're all different, so at least I know it's going to be scalene. I know that much. But I don't know whether I'm dealing with acute angles or right angles or obtuse angles. So how do I figure that out? Maya? Not divide. So this angle is 2x, right? What's the degree then? How did you figure that out, Ray?
Because the coefficient inside the variable, meaning we'll multiply it, so it's 2 times 15,
So,
which is 30.
so what did you do? You just substituted. All she did is she found, once we found what x was equal, substituted into each of the angles. Substitute it in. Instead of 2 times x, do 2 times 15. Okay, 2 times 15 is going to give us 30 degrees. What's 4 times 15? 60 degrees. What's 6 times 15? 90 degrees. Okay, so what kind of triangles? We know we're dealing with scalene. We already knew that. But what's the other one? Right. So it's a right scalene triangle. All right, I want you to do number 4 on your own. All right, let's go ahead and work this one out. We're going to set in as our first angle. And then it doesn't matter which one you wrote first. It's perfectly fine. I have 2x plus 20 as the next angle. And when I add all 3 angles together, it's supposed to be equal to 180. I then have to combine my like terms. So I've got x plus 2x. So that's 1x plus 2x. It's going to come out to 5x. Then I have a positive 10, a positive 20, and a negative. So plus 10, plus 20, and a minus 5. When I do that, it comes out to a positive equal to 180, and then I can start solving. I'm going to subtract 25 from both sides. That'll leave me with 5x, 5, and then I'm going to divide both sides by 5. And we'll get that x is going to be equal to 31. All right. So now that we know, so for the angle x plus 10, we're going to do 31 plus 10. That makes this angle 41 degrees. For 2x plus 20, that means we're going to do 2 times 31. 2 times 31 is 62. It comes out to 82 degrees. And then 2x minus 5, so 2 times 31 is 62. Comes out to 57 degrees. So again, we're dealing with a scalene because they're all different. And scalene triangle. Any questions? All right, you have IXL, 3 skills. 1 of them on classifying the triangles and 2 of them on solving for missing angles.